How you doing? I thought I'd show you how to do one of these 4-bit multiple gate tables. They're actually not too bad once you get the hang of it. And it's all just about breaking it down into manageable pieces. So what we'll do is we'll actually just look at the exclusive OR gate and its output. Then we'll look at the NOR gate and its output. And then we'll look at those two outputs and compare those into the NAND. So when I start, I always think about each gate itself and its particular outputs, its truth table. So for the exclusive OR, which is exclusively A or exclusively B will be Y, right? It's either where you have only an A or only a B do you have an output. When you have neither A nor B, it's 0, and if you have A and B, it's 0. So I'm just looking for a 1, 0, 0, 1 combination in the A and B column. So in these first two columns. And that's going to do an output over here in the Y column. So I'm looking for it. So first one, no. Second one, no. Third one, no. Fourth one, no. Fifth one, yes. There's a 1 there. Fifth one, 6, yes. 7, yes. 8, yes. Now here in the 9th row, you can see it flips from the B over to the A, but now it's 1, 0 instead of 0, 1. So now it's, oops, 1, 1, 1, 1. And then down here, it's A is 1, B is 1, so my outputs are 0. Now to keep the table from getting too cluttered, I'm not going to put in the zeros. I'm only going to put in the 1s for now. I'll fill in the zeros later. So now I can look at my second gate, which is C nor D is X, nor both. So here I got the truth table for the NOR. And you can see that it's only when I have a 0, 0 combination do I have a 1 in the X column. So I'm looking for a C0, D0, and only where I have 0, 0 do I have a 1. Will I have an X. So up here, oh, 0, 0, first one, yes. No, 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 yes, no, 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 yes, no, 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 yes, no, no, no. So there's only 4 outputs that are going to be high for that second gate. Now I can take output Y along with output X and NAND those together to get my output for Q. So if we look at the truth table for the NAND gate, well, the NAND gate is 1, 1, 1, 0. So anytime I have a 1, 1, I have a 0. All the rest of the time I have 1s. Now in this case, it's easier to do the 0 instead of the 1s because it's fewer cases. So anytime I see Y and X, oops, these aren't right. So I'm going to do X and Y, BQ. Well, then I'm going to put a 0. So a 1, 1 in my X and Y columns is going to be a 0. So I've only got the 1s to deal with. So 1, 1, oh, there's a 0. No, 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 no. 1, 1, 0. No, 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 no. So there's only 2 scenarios where there's zeros. And I hope you can see that by keeping the table simple, not filling it in all at once, these answers really stand out. Now I can go back and just fill all these in, and I will be done as soon as that is filled in. And it's really that easy. It's just about breaking it down into manageable pieces. I hope this video helped, and I hope that makes you realize that this really isn't that hard. Oops, forgot my 0 up there. And like anything else in this trade, break it down into manageable pieces. It's not about taking the whole big picture. It's about, oh, me screwing up and putting in a bunch of 1s. But you get the idea. No, it is a bunch of 1s. Yeah. There's only 2 zeros. The rest are all high. So there's only 2 incidences where I don't want an output. So there you go. Hope that helps. and good luck. I'll post the answer to the second practice table so that you can practice it and check your answers along with it. Cheers.